with form handling. So I will share my screen with you all. Hopefully you can all see that. And let's get started building and taking a look at Redux Thunk. So basically, the idea behind Redux Thunk is it's a way for you to handle asynchronicity within Redux applications. Probably the biggest single use of this is going to be when we're working with Ajax. So in everything that we've seen so far with Redux, we've dispatched an action and straight away that's been run through our reducer, and then that updates the state and our application re-renders. Well, that situation is a little bit more complicated when it comes to asynchronous stuff. So something like an Ajax request, because there's this delay in proceedings. So with Ajax, we need to go away and make our HTTP request, and then Google servers or GitHub servers or Facebook servers or whoever take a bit of time to respond, and then we get a response back. And at that point, we're going to want to update our state because we've got our response then. And so Redux Thunk is designed to basically manage this process of doing something asynchronous, like making an Ajax request, and then when that's come back, updating your state and making it show that your application shows whatever information you've just fetched, or shows that you've submitted something, or whatever it might be. So in order to show that off, what I've got a little application which is going to be hitting GitHub's API. So the idea is we'll be able to put in a username here, like Rails, hit fetch, and in theory that should go away, fetch a list of all of the repositories from this API endpoint. You can see this gives us a big old list with loads of information in. And then when it does that, we want it to come back and fill in this information here. So we've actually got that list of repositories showing up. So we're going to do all of this using this Redux Thunk library. Redux Thunk basically has a little bit of a setup stage before we get started. We need to tell React that we're using Redux Thunk. So we do that in our store. And so basically what we can do is we can import this Thunk library. So we import Thunk from Redux Thunk. And then this is basically what they call a Redux middleware. So you're already familiar with the concept of middleware from Express, right? That your request comes in and it goes through middleware until you eventually send a response and don't call next, and then that's your request done with. Well, there's kind of a similar idea in Redux. In Redux, we have middleware too. So what happens is an action comes in, so you dispatch an action, and then that action is run through all of this series of middleware. And then it gets to the end of all of your middleware, and then finally it's run through your reducer. So Thunk is basically a piece of middleware which is going to intercept actions along the way. And it's only going to intercept these asynchronous actions, so actions which are doing something asynchronous. And it'll do something with that, and then, that's basically the entire job of Redux Thunk done. So because it's a middleware, we basically add that to our store, which is where our actions all get run through. And we do that using another function called apply middleware. This is basically just a little utility function for adding new middleware to our store. So what we'll do is we'll say create store, passing the reducer as the first argument, and then we'll apply some middleware. And what middleware are we going to apply? It's that Thunk middleware. And so we'll save that, have a look, and our app looks basically the same. There's kind of nothing visible that's changed. But now we've done this piece of kind of one-time setup work, so we can create and dispatch our asynchronous actions, our actions which kind of do async stuff, and the right thing will happen to them, basically. I've talked quite a bit already. That's our little bit of setup work. Does that first part make sense to everyone? Do you understand kind of what we're trying to achieve and what that setup's done for us? Yeah, give me a thumbs up if it makes sense. Shout me a question if you got one. All right, fantastic. So next thing is we need to start creating our code, which will, actually go away and make our call to our API, and then in theory update our state. So what we're going to be creating is we're going to be creating our asynchronous action. So I'm going to create a new file called actions.js. Looks like I've got an old version of that. I can just delete it. And so in here, basically, we're going to be creating our first ever asynchronous action. So you know that synchronous actions were just objects, right? We had an action which looked like this, and there was an object which had a type of whatever, maybe a payload of some value. But at the kind of fundamental level, an action was just an object. So, question is, what about an async action? What type of thing is an async action? Is it another object? Is it an array? Is it a string? What is it? Right, an async action is just a function. So what I'm going to do is I'm going to create my async action. I'm going to call it fetch repos because that's what we're trying to do. And in fact, let's just make that a function. And there's nothing really special about these functions. They can be functions which do absolutely anything. In real life, they will pretty much always do something asynchronous because that's the whole point of this. But just to show it off to start with, let's just put a console log statement in here. So let's say I'm an async action. And that's basically it for our first simple async action. Now, in terms of how we actually use that, well, really there's no difference to a standard synchronous action. To use a synchronous action, we dispatch it and it's run through our reducer. To use an asynchronous action, we do the same thing. We just dispatch it and then it will be run through our Thunk middleware, and we'll take a look at what happens. So I've got this app.js which has my form. This is already connected up to get some information from the state in. So on submit, what I'm going to do is I am going to logging out what I've typed in the input. Let's also say this.props.dispatch. Remember that dispatch props coming in because my component's connected. And I will dispatch my fetch repos function. Let's import fetch repos from actions. I'm trying to make sure I'm exporting that. And so I submit my form, and we see that basically it logs out that it's an async action. So what's happened here? Well, we've dispatched that asynchronous action. So we've dispatched a function. You'll notice that we haven't actually called that function. So there's no kind of parentheses here. Run lots of things. Let's see. Where do I import it? Which repos from? Yeah, you'll notice that we haven't called fetch repos here. We haven't said, okay, let's call that function and then the result of that gets dispatched. We've just dispatched the function itself. And that's run through our middleware chain, and it basically hits the thunk middleware. And the thunk middleware is really simple. It basically looks at what we've dispatched, and it makes a decision about what it should do. So what it does is it says, okay, is this an object? If it's an object, then it's just a regular synchronous action. We'll let it go through. But if it's a function, like this, then it says, okay, what I'm going to do is I'm going to call that function. So the thunk middleware has called the fetch repos function, which we passed in, basically like a callback. And that means that it's, this function's been called and it's logged out, I'm an async action, which is why we see this being logged out here. So that's our first really simple async action. Does that bit make sense to everyone? Do you see what an async action is? And do you see how by dispatching it, it gets called? Give me a thumbs up if that makes sense. Shout me a question if you got one. All right, cool. So let's keep going. Now, I used a kind of analogy here, right? I said that we had our actions, which were, had a type of foo and some payload, and they were just objects. And similarly, our asynchronous actions are just functions like this. Now, when we were working with synchronous actions, we kind of went one stage further and said, okay, here's our synchronous action. But in order to allow us to, make copies of that synchronous action easily, what we're going to do is we're going to make an action creator. So what we said is okay, let's do something like this. Action creator is a function which returns that object. And then by calling our action creator multiple times, we could create multiple copies of that action. So like action 1 is the result of calling our action creator. And then action 2 is, another action which is the result of calling our action creator again. Now, basically, we could kind of use an analogy, and we do the same thing with asynchronous actions. So whereas a synchronous action creator is a function which returns an object, so a function which returns a synchronous action, an asynchronous action creator is a function which returns another function. So it's a function which returns our asynchronous action. So what we can do is we can say, okay, rather than exporting our async action itself, we'll export an async action creator. And that will return our asynchronous action itself, which will just make an anonymous function now. So nothing too clever has happened here. And then we can, obviously create copies of our async action in the same way by calling our async action creator function. So really all we've done here is we've wrapped our async action in another function, and that function is returning that async action. So what do we need to change here? Well, now fetch repos isn't an async action, it's an async action creator. So we'll call that, which will return this inner function. And this inner function is the thing which gets called by Redux thunk. So we should see the same thing getting logged out. So really just a kind of extra level of indirection here, that we've got an extra function wrapping our inner function, and we call that to create our async action. So if I save all of that, and submit, you'll see that that's still saying I'm an async action. Interesting. Actions must be plain objects. I have a feeling I just haven't saved something here. Yeah, that's right. If I do that, then yeah, you can see I'm basically back in the same place I was. It calls I'm an async action from Redux Unc. And so we've got our async action creator. You might see this written as arrow functions too. So if we were to, write the same thing as arrow functions, it would be something like export const fetch repos is a function which returns another function, and inside that inner function we're doing a console log. So you can see that the syntax is a bit shorter, and it's pretty terse, this kind of arrow followed by arrow, but it's basically the same thing. It's one function which returns another function which has this as the body. Switch over to that, and in theory we see the same thing. We do a submit that calls the outer action creator, and then Redux then calls the inner action. Does that bit make sense to everyone? Do you see how we've gone from just an action, so just a function, to an action creator, so a function which returns that function? Give me a thumbs up if that makes sense. Shout me a question if you got one.
Hi, Joe.
Hey, George.
Could you go over one more time? Is that possible?
Yeah, of course, yeah. So, again, I'll kind of follow this analogy through, right? So, before we had actions, which were objects with a type, right? And then to make it convenient to make multiple copies of those actions, we made an action creator, which was basically a function which returned one of those actions. Well, here all we're doing is the same thing. So what we've got is we've got our action, which is an async action this time. So I guess I'll call this async action, which is just a function which does something. And what we're going to do is we're going to make a async action creator, which similar to our async action, it's similar to our action creator, it's a function which returns the async action rather than returns the sync action. So it's a function which returns this whole thing, with some horrible copy paste things going on there. And so that's the only change we've made, is that now there's kind of an extra action creator function which is returning copies of those async actions, copies of those functions. And so we call the async action creator to produce the async action. We could split this up. We could say, okay, async action is the result of calling fetch repos, and then we dispatch the async action. So we dispatch that function. Does that make sense, George?
Yes, thank you.
Cool. Anyone else got anything on how we've kind of moved over to an async action creator that they want me to take a look at? Cool. In that case, I'm going to keep moving. Next, let's take a look at what we're actually going to do inside our async action creator. So we've got this function. As I said, you can do anything you like within it, but you tend to do something asynchronous. So now what we can do is we can put in our code to make our AJAX request. Let's see, I'm not sure you've seen this before. Can you give me a thumbs up if you've used the fetch API before, and a thumbs down if you haven't? that's enough downward thumbs for me to think it's worthwhile taking a look at. So the fetch API is basically just a kind of different way of making AJAX calls, and it's built into the browser, which is kind of the big advantage of it. It's a relatively new API. So this is going to be doing exactly the same thing as you were doing with jQuery's AJAX, but without us kind of requiring an extra library. So let's see how it works. It's a relatively simple, relatively kind of small library. So what we do is we call this function called fetch. And at its simplest, if you just want to make a GET request, all you have to do is you have to substitute in, you put in as an argument the URL which you want to grab. So this is the equivalent of saying, $.get and then some URL. Now, in this case, I want to make this variable, so I don't always want to get the same user. I want that based on whatever username I type in. So let's just quickly make it so that we can vary that by passing in an argument. So I'll pass in my username there. And I will substitute that in here. And similarly, I'll here pass in the input value, so that makes that fetch request. And I'll save that and switch over to my network tab. Don't know whether this works until I put a .then in, we'll see. So let me try to go to the Rails user, hit fetch. I don't want to just look at CSS. And you can see that, I'll do that again just so you can see it. Let's try Thinkful. It makes a request to API github.com, users Thinkful repos, and you can see that it's gone away, made that request, and there's some information in my response. So it's very simplest. We just say fetch, say the URL, and it goes away and does it. If you're doing things a bit more complicated, you can put an extra object as the second argument. This is basically options. So things like if I wanted to make a post request, I'd say that the method was post. If I wanted to set some headers, I would say that, these are my headers. There's various different things you can put in these options. But for now, I'm just making a straightforward GET request, so I'll put nothing in there. And fetch returns a promise. So what I'm going to do is I'm going to put a .then, and you get a response object back from that. So this response object, console log it. What have we done here? I think. Curly brace, maybe not. And I need to put an actual name there. Yeah, and you can see that we get this this response object. Thomas, would I do a myinit var for fetch? What do you mean by that? I'm not sure exactly what. So make a variable. What you may well do is make a variable options like this, which says that your method is post. Yeah, that's really, really common, and then you just pass that in as your second argument. So yeah, that works in the same way. Yeah. Let me drop my .then now so it's readable. Anyway, so we chain on our .then, we get our response, and that comes back as this response object. And that's got various information. It's got information about our status, which was 200, it all went okay. It's got this OK, which tells us that it went okay. It's got a type of cause, a URL, and so on. For the moment, I'm going to basically ignore error handling and just assume that this all went okay. Now, with the fetch API, there's kind of an extra step that we have to go through. So, like Thomas was saying, with jQuery, we could explicitly say when we made the request that we were looking for JSON. With fetch, it first of all grabs the data, and then you have to go through an extra step to decode that data. So if it's JSON coming back, you decode the JSON. If it's text coming back, you decode the text. And the way you do that is basically by returning, and then you call the method of the response. So spend most of our time working with JSON, so you'll return res.json. And this function basically returns another promise which decodes your JSON for you. So what you do then is you chain on one extra then, and this will be our data that we've got back. And we can just console log that data, something like that. So if I search for people and hit fetch, you can see that's logged out all of this information that it got back from Thinkful's repos. If I search for Rails, that will log out all of these different repositories that are part of Rails. So that's a kind of first big, and I guess main big difference from doing this using jQuery's Ajax is we have to have an extra .then in the middle, which will grab or will basically decode the response that we get back. One thing to be kind of mindful of is that this is a different function to Express's res.json. So res.json in Express is saying send back this information as a JSON response. Res.json in fetch is saying decode the data that we got back from the response. I will introduce kind of more little features of fetch as we go through the next couple of weeks and so on. But that's a kind of really quick first go at it. Did that make sense to everyone? Do you see how to use fetch to grab information as an Ajax request? Give me a thumbs up as ever. Shout me a question if you got one. Okay, cool. So we've got our data for our repositories. Actually, the first thing I'm going to do quickly is I'm just going to map over it to get rid of lots of the nonsense, because all we're really looking for is the name here. So let's change this. So we map over it, and we just get the repo name. That will do for what we're looking for. So if I do that, you can see that I just get a list of names rather than all of that extra information. So what do we want to do next? Well, we've managed to fetch that list of repositories, and now we want to put that in our state. So if I have a look at the state as it is at the moment, you can see that we've just got this like hard-coded initial list of repositories, so we can see something up in display. So what we want to be doing is we want to be replacing this with the data which we fetch back from our asynchronous action. And actually, the way we're going to do that, you know already. We're not going to do anything clever here. All we're going to do is we're going to basically make ourselves a synchronous action. So our method for updating the state stays the same. We dispatch a synchronous action. It's just that we're doing that from a different place. We're doing that from within our asynchronous action. So what I'm going to do is I'm going to make myself a synchronous action here. And I've got a nice little shortcut for doing that. And I'm going to call this fetch repo success. And this fetch repo success action, we'll look a little bit more about the naming, but basically you kind of tend to match these up. So if your asynchronous actions fetch repos, then you'll have a fetch repo success for when it's all gone well. So here's my action. Let's have a payload of that, which is my list of repositories. So basically, we're going to pass in what we got here. Now we've got our synchronous action, which should be able to update the state. Next question is, okay, how do we actually run that synchronous action from our asynchronous action? And again, it's basically the way that you know and love. You dispatch the asynchronous action. We could do this in a couple of ways. So similar to with the components, we could import our store here. And then in here we could say, store.dispatch our fetch repos success action, passing in our information from the AJAX request. But again, this is another place where they like to kind of decouple the actions from the store. And the way in which you can do that is basically your async action itself, Redux gives it dispatch as its argument. So this will be past that dispatch function, and then we can use the dispatch function to dispatch our action. So here we dispatch fetch repo success. And if I just put a console log in my reducer, so we'll log out any actions which are run through there. And this tends to be a kind of nice sanity check just to have at the top of your reducer so you can see what comes through it. If we do that, then if I search for Rails, you can see that goes away, and we get our fetch repo success coming through our reducer with that list of repositories with all of the information in there. What we've done here, we've made that synchronous action which pairs up with our async action, and then we dispatch it from our async action when everything went right and was all good. And the last stage of this is to handle that action in our reducer. So, just the same as if this was any old synchronous action, which we dispatch from any old component, we handle it in our reducer. So we can say, okay, if our action type was a fetch repo success action, I guess I need to import that. Then what do we want to do? Well, we want to update our state object. And so we're going to be using object.assign because we don't want to mutate that state object at all. Our first argument, empty object, because we're creating a new object here, we don't want to be overriding things. Our second argument is going to be our state, because this is the thing we're updating. And then what do we want to do? We want to update the repos part of the state. And rather than pushing to the end of it or anything, because we're fetching a completely new list each time, we can just completely override this. So we can say that that's equal to our action.repos, something like that. And that will just completely replace whatever was in repos to start with. And if I save that, export, it's a named export, so I need to do a named import. If I now do my search for Rails, you can see that it's updated with all of that asynchronously fetched data. For Thinkful, does that. If I search for, I guess Angular probably have one somewhere, find all of the Angular repositories, so on and so forth. So that's basically that last step. Once we've made our asynchronous call, when that comes back and tells us it's all good, then we just work in a standard synchronous way. So we have a synchronous action, we dispatch it, we handle it in our reducer, and that updates our state. Does that last part make sense to everyone? Do you see how we've gone from getting the data to actually making it show up in our app? Yeah, give me a thumbs up if it makes sense. Shout me a question if you got one. you can sort of play a game with the synchronous part too. Like you can almost forget about the asynchronous part and just test out the synchronous part separately. So what I could do to like try that out if I wanted a kind of intermediate stage before going like the full asynchronous route is I could in my app.js import that success action. And then, on submit, rather than dispatching my asynchronous action, I could test out dispatching my sync action. Success, forget about thunk and asynchronicity completely. Where, this is like... And this is like a nice little tip for testing out your synchronous actions. Is, you can dispatch them and test them out just the same as normal, and then switch over to actually use them within your asynchronous action once you're confident that they're working. So that's most of the way there. That's like all of the kind of real hard meaty stuff in order to get asynchronous requests working. I just want to talk a little bit about some kind of patterns for doing this nicely. So I'm sure you've all experienced this before, right? You go away to a kind of e-commerce site, you want to buy something, and you add the thing to your cart and you type in, all of your details, you type in your bank card and whatever, and you click purchase now, and nothing happens. And you have this sudden moment of panic, which is like, did I actually click the button or did I miss it slightly? Should I click the button again? Because I'm not sure whether it's ordered or not. Like if I click again, will I order it twice? If I don't click, will I have not ordered it? And inevitably, 30 seconds later, their servers finally get through processing it, and it pops up and says your order's complete. And all of a sudden, you feel that wave of panic dropping away from you. Well, this is the kind of thing that we tend to want to avoid with our users. That wave of panic is not a nice thing. So what we really want is we want some kind of more checkpoints along the way, rather than just having a bit of state and a bit of information, which is like, cool, everything went okay. We could do with some intermediate things. So something which is saying like, hey, okay, we've started to do this. So we're processing it. Just hold your horses, wait, don't worry, and we'll get around to it. And something which says like, oh, sorry, everything went wrong our end, so you're totally safe to resubmit and make your new order. It's just that something temporarily went wrong. So the way that we can go about this is basically there's a pattern which we can use where rather than one synchronous action for every async action, we have 3 synchronous actions which control those different parts of the state. So what I'm going to do is I'm going to add a couple of extra pieces of state here. I'm going to add one piece of state which says whether we're loading or not. So this will start out being false. It'll switch over to true when we start making our request, and then it will switch back to false when the request's done. And I'm also going to have a bit of state which is called error. And basically this will contain information if an error happened, so we can tell the user what went wrong. So a couple of extra bits of state, and then we can use them in our component. So let me map those in. So loading would be state.loading, state.error, and then I should probably handle these in separate components, but as a kind of quick and dirty thing, I'm just going to create LIs for each of the cases. So I'll say something like, okay, if this dot props dot loading, our repo list is an LIE saying loading. Otherwise, if there's a error prop, show the error. Otherwise, we assume everything's gone right. And I can just test that out by kind of hard coding these values. So if I set loading to true, then in theory we should see loading. If I set my error to something, then in theory we should see the error and not any kind of previous list of repositories. So we've got our bits of state in, we can see what's going on. Last thing that I have to do is create those kind of synchronous actions which are paired with our async action and handle them in our reducer. So, as I said, with each action, with each async action, you tend to have 3 synchronous actions. One of them is the request action. Basically, we've started to make the request. So this is where we'll say, yeah, it's loading. And you don't tend to put any extra data with that. So what we'll do is we will dispatch fetch repos request right at the start here. So, before we make the fetch request. Yeah, Judy, that's a Vim thing. I'm using a little snippets library which lets me do that. If you're using VS Code, in fact, I can't remember who it is, but one of the big snippet libraries for VS Code is maintained by one of our Thinkful mentors, I think. But anyway, you can pull up if you search for VS Code, there's a bit of information which tells you how to create your own, and you can pull some in from the marketplace too. So it's a nice thing. It's a fairly kind of quick and easy thing to set up, and it speeds up this a lot. Cool. So yeah, when we make our request, just before we do our fetch call, we dispatch that fetch repos request. This will basically say we've started loading it. And if everything goes wrong, I will add a catch block. And in here, we'll dispatch a fetch repos error, which says something like something wrong. So we'll have that action fetch repos error, and in there we'll pass whatever the error is. So you can see we've gone from basically one synchronous action to these 3 synchronous actions, which all get dispatched at different points. In order for this to happen, I probably need to deal with my error handling. So in here, I'll say something like, if the response wasn't okay, so if it wasn't a 200 response, everything went wrong, then I will return a rejected promise. Pass that in there and then use that as my error message. So basically this says, just check that the response was okay. If it wasn't, then we'll send back some information about how it went wrong. So I've got my 3 synchronous actions which get dispatched now. One right at the start, one if it all goes well, and one if it all goes badly. And all that's left to do is basically handle those in my reducer. So let's make copies of that. Import both of those. Right. So one for test, one for request, and one for error. And then really it's just a matter of setting the right things in my state. So if we started making our request, then we'll say that it started loading and any error's gone away, presumably. If it was successful, we know that loading has stopped. And if there was an error, then we know that loading has stopped also, and we can set our error to the error from the action. So just a little bit more code. This is kind of boilerplate. You'll write it again and again and again, setting these various properties. But what this means is that now, let's see, I'm probably missing a parenthesis. That tends to be the case with these. So now you might not be able to see this because it's probably a little bit quick. But if I search something which exists, can you see it switches over to loading quickly and then it comes in. So the user's a bit more aware that something's going on. They don't just think they've hit something and nothing's happened. And if I search for something which doesn't exist at all, then I see loading quickly and then I see something went wrong because I tried to fetch something which wasn't right. I got a 404. So there's just a little extra pattern around this to kind of give your users a bit more information what's going on. You won't need this every time, but especially in those kind of key interactions. So things like making purchases and places where your user's likely to worry about nothing going wrong. Then it's really useful to have that extra bit of feedback. And I think that's pretty much it from me. Does anyone have any questions about that last bit or anything we've had a look at today? All right, cool. So I guess the last thing from me then. Yeah, of course, Thomas. I'll chuck this up as a gist so you can take a look and have a play around. In terms of what you're going to be working on today, basically today is all about drills. So there's two sets of drills. This morning you're going to be working on this first thunk drill. And then, as I said, at lunchtime we'll take a quick look at React Router, and then you can work on the router drill and finishing off the thunk drill in the afternoon. So for the thunk drill, you're going to be working on something pretty similar to what we've been looking at. Basically setting up async actions which search the Star Wars API. So you'll create that asynchronous action, create the kind of corresponding synchronous actions, and creating the reducer which handles all of those. One thing to note here, you won't be making the fetch calls completely from scratch. There's a function which is pre-written for you, which is designed so it adds a little bit of delay so you can see loading indicators, and so it fails sometime, called search. And basically search just returns a resolved or rejected promise. So your code, rather than writing the fetch from scratch, is going to look something like return search, and then you'll search for a character name, so search for Luke, .then, and then you'll get back your character list straight away to do something with. So actually, having taught you quite a bit about fetch, you will be using this later, but this morning you're not going to be writing like all of this code. You can directly use this search function which is provided for you. So just a quick note on that. Otherwise, I think that's everything from me. So if you want to jump into your pairs, get working on that thunk drill, and I'll be around, so grab me on TA Tickets if you've got a question. Otherwise, I'll catch you all back here at lunchtime to take a look at React Router. Thanks, everybody.